Oh, okay, we're back. All right, we are going to continue from our last session, which is about still continuation. I think part 8 right now of the micro course of the machine learning from Kaggle. Bear in mind, I'm also learning, although I have a degree in kind of, you know, engineering, but this is kind of like a new field for me, data science. So we are already creating a model, right? Trying to predict the home sales price value. I think in Iowa, the data, right? And then we already submitted, and I got about 7,000 ranking on 7,000 on the Kaggle competition, which already kind of close, but they're still kind of open it just for playing purpose. So um, at our previous session, if I'm not mistaken, we choose like seven features uh, of the important features from we think what is the most important factor determining the housing prices, right? For example, like just like the first floor square footage, the second floor square footage, whether there's a the year built, probably years old, and how many bedrooms are there, and what have you. And they're all numerical data, right? So that's good, all in good. Um, we submitted the our predictions, and I got 7,000, right? Right. So we are trying now to improve upon that. So there's many ways to improve it, right? One of the obvious ways is you increase the number of features, which is to increase the number of factors that you think it's important to determine the housing factor, right? Um, so uh, we are trying to do that, and in this setup, in this um, exercise, we are going to do uh, just that, incorporating all of the features, particularly um, all the numerical features values. So we are throwing away all of the non-numerical, which is the categorical values, which later on the later session we're gonna trying to incorporate that, right? The categorical values. But right now we are just concentrating on the features that are numerical. And but we have a problems because some of those features has missing values, like none, right? Missing value means there's no value. It's not just zero. It's just there's no values, not applicable. So what do we do? Okay, so here we gonna go through this thing again. So this is just a setup for checking whether the the code is correct or not. Um, so we're gonna again doing the same thing again, importing the pandas and then importing the train test split algorithm, right? And then we're gonna read the data from these input train and input tests. Um, so we're gonna just do that. Um, this one I'm just trying to read the shape of the X full, which is has 1,460 um, uh, sorry rows, and there's 80 columns. 80 columns means like 780 features, but I think the first features is like the the ID, so it doesn't count. So probably there's only like 79 features, right? Um, we can we can see how it looks like. It's kind of slow because everything is like going on at the same time here. So if you can just X full, um, what's that? Shape? Is it shape? I'm not sure. No, it's not shape. It's head. Just want to see what it looks like. There you go. Yeah, so this is what it looks like. Basically, so it includes the sale price here, right? And later we're gonna take that out because we want to use that as our output, the y, right? Uh, so the next thing we're gonna do is we're gonna drop. So this is removing rows uh, with missing target. So just the no rows that with missing target, just for precautionary purpose. But I think there is no rows that have a missing target. Everything has a target. So the missing target, I think, is um, the sale price because that's the target, the output that you're trying to predict, right? So and then we're gonna put the y, right, over there as the sale price, and then we're gonna drop um, the sale price for the x, and then like I mentioned before, for this purpose, we just gonna concentrate on the numerical predictors, right? Numerical. So we are going to drop, for example, street features because this is not non-numerical, right? This is called categorical. Later we're gonna learn more about that. MS zoning is also categorical. Anything that's non-numerical, line contour, utilities, lot configuration, pull QC, fans, miscellaneous features, cell tab, cell condition, all of these features, like we're gonna drop it, yeah. And this is basically the code for that, yeah. So we're gonna do it for the X, right? And then we're gonna do it for the X test for the testing. Hmm, I don't know why you have to do that. Anyway, so and then we're gonna use the validation and the training. So we're gonna use this thing again, right? We're gonna use 80% to 20%, 80% for the training, 20% for the testing. Random set 0, you can put it in a 1 or 2, doesn't matter. It's just to make it reproducibility. Um, so what are you putting here? You want to put the x, right? Um, which is all of these things without do the just the numerical. Um, that's what x is, and then also we're dropping the sale price, right? Um, and then the y is basically is just the sale price here, right? So that's what it is. Okay. Uh, yeah, I'm not sure what is this. The X test here. It's not being used basically. Anyway, so we're gonna run this, right? And then we can see, for example, the X train right now, um, the shape, right? So it's slightly, it's like half. It's only 36, right? As compared to the original one, there's 80 columns, right? So because we're dropping all of the non-numerical kind of what do you call it, features, right? We want just to concentrate on the continuous, which is the numerical one, right? In this case. And then we are also dropping some of the so if you look at the full shape of the X is 1460, while over here is only 1168, right? So why there's a reduce about what 300 like rows because we are just getting the training, right? We are just getting the 80%, right, of the which is correct, right? So if you 80% times this guy or 20% minus this, which is about 300, right? So it's about 1100, right? So which is this guy, right? So okay. Um, I hope you're still following me here. If you have any questions, just feel free to ask. And then uh, you can also see the X, for example, X valid. This is the 20%, the remaining 20%, right? So you can see if you plus this should be equal to what is this? 1,460, I think, right? Yeah, my math is a bit, yeah, times two, I think so. Okay, so that's the one, and then so we're gonna do a preliminary investigation. So this is just gonna print out the ship again. We already know the ship, which is this one, and then we're gonna print out the missing value count by column. So so we got three features that has kind of missing values, right? Lot frontage, mass, I think it's mass um, inner area, and garage your built. Um, so what are we going to do about this? Do we bear in mind this is like 212, so it's pretty significant. So out of this, if you look lot frontage here, so this one is just showing you just the top, the first five, right? But if you want to scroll down like the whole 1100, whatever, for the training purpose, there's going to be kind of 200 over missing values according to our investigation, right? 212, right? So what do we do with that? Do we drop these features, right? Because it's kind of like um, annoying or kind of like um, disturbing the machine learning algorithm while we are training it because there's so many missing values. Or do we it's called imputation. Do we put like a median values? So the median values is basically the values that in the middle. So you see all of the values here between 65, 80, 68, 60, 84. So probably, for example, it's the values between 60, right? 60 to 84. So in the middle is like what 14 is 7, so 67, right? Is it 67? No, 24. It's 12. 72. So should they put like all of those um, non-applicable, like the non, you know, the missing values as the median, which is 72 in this case, or do you want to put some other number, for example, the average, or we can use a different approach. So in this case, it's like any ball game, right? You can like think of it like a uh, different way of uh, uh, ways of trying to solve this problem, right? Um, but as a guideline, you want to use kind of uh, the this MAE algorithm, which is the mean absolute error, right? You want to minimize those, right? So we'll see. So in this case, we have 1,168, right? The rows, right? So if you look at the rows, there's like 1,100, like 1, 2, 3, 4, 5, and 1,168, right? And then we have three features that has missing values, number of columns, right? And then the total number of missing is 276, right? And then the one that has missing values as uh, this one. So if I were to use like kind of the dropping features, which also I'm not sure that dropping is the best way, right? Probably I would drop this because this one has the most kind of number of the uh, has missing values, right? Definitely, I wouldn't do it on these features, the mass linear area, because it's only six. I'm also kind of very sure not gonna drop the garage your build because it's only 58 missing features out of the 1,600. That's like uh, probably only about 4%, well, this one is not even 1%, right? This one is could be like around about more, almost like 20% kind of, right? So probably I would drop this, and then I would like do kind of do this and this like a median values. I'm not sure, and then I'll just check the mid compute the median absolute error and try probably different ways. Probably just do like average instead, or do everything average, right? But there's different ways of you can think about how to solve this problem, right? So okay, so we're just gonna run this, right? Just to check it agrees with the solution. So it's the correct solution. So um, so what are you gonna do with the missing value? So the from the exercise over here, we are the first method or the first approach we are going to try is just to um, um, let me see. So it's less than 20%. Um, so we can expect the dropping columns unlikely to yield this because we'd be throwing a lot. So imputation would likely perform better, right? Okay. So here we're just gonna do the function, write the functions, and then we're gonna do the one way of doing it, which is the dropping the columns, um, which I wouldn't recommend um, to do this because the missing values is not justifiable enough. Uh, it's not big enough. If I want to do the drop column, probably I would just do it sparingly. I would just do it on the one of the features, not all. But okay, here we go. So um, so we are dropping the features here. Sorry, dropping the columns, right? Or the features, right? Um, and then this is the column with the missing. We know already about this. There are three features, right? So this is the reduce um, X without that column, without this three specific columns. So if you notice, this has been removed, right? So if you compare this one with, let's say, the one at the front, right? There's this lot frontage, right? I think this is the one that being dropped, right? Lot frontage. Am I correct? Lot frontage. Yeah. So over here, the reduced one, it's gonna be dropped. So you don't see lot front. There's no more lot frontage over here, right? So it's being dropped. And then after that, we are going to print the mean absolute error, right? So we're gonna use the reduce X train, the reduce validation because we want to compare, right? Remember the training and the validation. Um, we want to see how big of the difference, right? It's always the mean absolute error is always comparing between the training and the validation, right? So, and it turns out it's about 117,837, blah, blah, blah. And then, so this is the another approach. It's called imputation. Imputation just means basically you are replacing the missing value. So instead of dropping the features, the whole column, right, um, which is not advisable, you're just gonna replace the missing features. Now, to replace it with what? That's another question. In this case, we're gonna replace it with the median values, right? So we call that as an imputed X train and an imputed um, X valid. So we are going to import again the algorithm from sklearn.impute. It's called simple imputer, and then uh, we're gonna put it into the imputed X train. So we're gonna call that and then gonna fit it um, transform on the X train, and then we do the same on the X validation, right? Um, and this one is putting back the um, um, the column. Yeah, putting back the column. Um, because imputation remove column names, so we're gonna put it back. Okay, got it. Hmm. I wonder what's the difference here. I want to separate this, for example. Uh, I want to see what's the difference. Seeing is believing. So I'm going to separate that, and then I'm just going to delete that. Okay. It's kind of slow. My computer is not very powerful, so I'm just going to run this one. Oh, no. That's, is that correct? No, that's correct. Okay. I'm going to run it, and then I'm going to check what does it look like. So I'm just going to impute it X train, and then Bobby shape. Oh, it's not callable? Really? Huh. You cannot call the shape? Or is it, hmm. Oh, okay. So just dot shape. Okay. You don't have to put, where is that? Where is that? Come on. Come on, baby. Where are you? Oh, okay. Okay. Just like this. Okay. So 1168.36. Okay. And then this one, you're putting the column name back. Not sure about that. Okay, let's see. I'm not sure what's the difference. Imputed xtrain dot shape. I think it's the same. Where is it? Where is it? Yeah, it's the same. So I don't know what's the difference. It says here input imputation remove column name. Oh, I just put it back. Okay, got it. Okay, I think I'm just gonna um run this one more time. Okay, run this one more time, and then what I'm gonna do is just print the head so I can see. There you go. Oh, that's what it means. There's no the column name is gone. Okay, got it. Okay, that's what it does. Just what exactly what is described, right? I just want to make sure. Okay, so this one is putting basically the name back. There you go. Okay, I got you. I got you. Hmm, interesting. Okay, so what is this? So okay, so we're gonna print out the imputed X ring, right? We're gonna compare that with the one that's being dropped, the feature. So what you're gonna do is you call um, the score data set. Um, um, where is that? Where is that score data set? Print score MAE. I just want to see what's the algorithm here. Um, oh, here we go. Score data set. Okay, yeah. This is basically using the random forest regressor, um, using a specific parameters, and then fit, and then you call the predict, and then you return the mean absolute error. Okay. Okay. Cool. So bear in mind this is 178,037, right? The mean absolute error for just dropping the features. You will see something interesting here that I didn't expect, kind of. So we're gonna print out also the mean absolute error for the imputed, and it turns out it's kind of bigger than the mean absolute error, the one that's um, you just drop the features, right? Why is that? I don't know. I don't know why is that. Uh, the only uh, thing that I could think of is the approach of replacing the missing values. Like I said earlier, you can replace the missing values in many ways, right? So um, over here, we are just replacing the missing values just using one approach, which is just replacing the three features or the three columns that has missing values, about 200 something values, with just the median data, right? But what if, right? Uh, we use average, we use mode, we use different way of or combinations of replacing it, right? Um, we'll see what's the Kaggle has to say about this. So the solution, it says here, given that there are so few missing values, we expect imputation to perform better than dropping columns entirely, right? However, I'm just gonna make this bigger for you guys to see. Oh, however, we see that dropping columns perform slightly better. While this can probably partially be attributed to noise in the data set, another potential explanation is that the imputation method is not a great match, right? Right. That is, maybe instead of filling in the mean value, it makes more sense to set every missing value to a zero. Could be. We can test that. To fill in the most or most frequently encountered value, or to use some other method, right? So because right now we are using mean, right? Just the average, or it's not the median. We can see it from here, I think. Oh, where does it say the mean? Oh, I guess it's this kind of the default. Okay, it's the mean. Okay, all right. So, um, for instance, consider the garage year built column, which indicates the year that the garage was built. It is likely that in some cases, a missing value could indicate a house that does not have a garage. Okay. Yeah, so not all missing values could be replaced with a number. It could be just zero, right? Does it make more sense to fill in the median value along each column in this case? Or could we get better result by filling in the minimum value along each column? It's not clear what's best in this case, but perhaps we can rule out some options immediately. For instance, setting missing values in this column to zero is likely to yield horrible results. Yeah, I agree with that. Except only for this garage you're built, right? But if you put like set missing values to column to zero for the other features, which is where uh, we have three features, right? Where is that? So I think this is mass is like an area. It doesn't make sense to put zero as an area, right? Also the lot frontage is kind of like a square footage, like an how big is the lot at the front, right? So it doesn't make sense you put zero. There should be like a number, right? Only this one, right? So we just have to. This is why I think the kind of the domain expert kind of plays in, like can give a valuable insights of how you can replace the missing values. And then what do we do here? So next we are going to try to compare it with using imputation, but we're replacing the missing values with I think with median. Yeah. So step 4, we're gonna generate a test prediction. So in this, you'll use any approach of your choosing to deal with the missing values. Once you process the training and the validation, you'll train and evaluate a random forest model. Okay, then you'll pre-process the test data before generating prediction that can be submitted to competition. Okay, so we use the next code cell to pre-process the training and validation data. Okay, set the pre-process data frame to final X train, final X valid. Okay, so we have to ensure that the data frame has the same number of column, um, have no missing value, and then the X train and the Y train has the same number of rows, right? Otherwise, it's not going to match, right? Um, which doesn't make sense, right? Also, the valid, the final X valid and the Y valid have the same number of rows, right? Okay, so here is the strategy is being used is median. So we are basically gonna replace. So if you look at the previous simple imputer, it doesn't say anything. It's just like this, blank. So I think if it's you leave it blank, it's gonna default into a mean, an average. Um, but this one we put strategy equals to median, and then we are going to put the final imputer called dot fit transform, put the x train, the same thing as for the x the validation. Um, once we once we do that, so basically this is replacing all the missing values with a median, right? And then we're just gonna double check whether it's correct. So it's kind of it's correct, right? Oh, you need to put um, you need you need to put the column. I forgot to do that, but I guess you can get away with that. So next we're gonna use that the final X train, right? So if you wanna over here uh, final X train, I think this one is still without the dot head. I think this is without the name of the column still. Yeah, there you go. Um, It is fine. We can get away. So we're gonna use now that specific um, input already. We already kind of clean it up or not clean it up. Just make sure there's no missing values, right? All the values are there, and using a specific strategy, which is the median strategy for all the missing values, which we think the replacing missing values is better than just dropping all of the whole column or the whole features, right? For that specific features. Um, okay, so now we're gonna call the random Ferris regressor again. Use the same n estimator 100. So we're gonna fit it. When we fit it, we use the final X train, um, which is basically using a specific median strategy of imputation, dropping the missing values with the median values, right? Um, and Y-train, and then you call the predict. When you call the predict, you put basically the final X valid, right? And then you gonna compare that the prediction value with the Y value, which is which is this is the real kind of output, and then this is the predicted output, right? So okay, this is good. So when you this is to train meanings to get all of the parameters for the the mathematical function or the model, right? So when we train again, we use the x and the y, but in this case, the x we want is a modified x. We just want the x that has numerical values. So we drop all the non-numerical values, and we make sure all of those numerical values, um, the one that has missing values, we want to replace that with the median strategy, right? So that's why we kind of modify that, and that's modification is called final X train, and the Y train is just the Y train. And remember, all this thing is just 80% of the whole training data. And then once you got the model, um, you want to use that model to predict the output, right? So you call again the model, right? And then you call the predict method. And then what do you put inside? In order to predict the output, you need to put um, again the x. But what x should we put? Is it the train x or the validation x? You have to put the validation because this is where you want to validate. You want to compare, right? Whether if your model it's ready for the real world. You cannot use the same data set as you train. You have to use a different data set because if you use the same data set, then your prediction uh, kind of is like cheating, right? Because when you train, you use kind of, let's say, this data set, and then when you after you train it, you got the algorithm, and you use the same data set to validate it. It's like um, kind of cheating. Yeah. So we have to use, remember that we have to use the validation, right? So we'll get to you all of this like concept when you use the training, when you use the validation, but basically you use the training to get the model the first time to get the model, and you use the validation to validate on the model that you already uh, trained using the training data. Okay, and then after that, um, you get an output basically. It's called prediction validation, and you compare that output with the real output. So over here, the real output is the Y valid, and then this is the prediction. And then you want to compare it with using this mean absolute error algorithm because you want to minimize it. You want to see how big or how small is the number. So we're gonna run this. So over here is hundreds, what, 17,791 is almost the same as if you look at so this one is higher, the one that's we use average, right? But when we use the mean, it's actually lower, right? But when we just drop the whole thing, it's lower. It's 178, right? 37, is it 179? Let's see, um, where is that? Yeah. Oh, so it's lower actually. It's lower by like 100 points, kind of. Yeah, it's 177, and then that one is 178, right? So it's slightly lower. So it's good. This is working the strategy, right? So and the rest is kind of just like trying to put it um okay. What are we doing here? Um so we are used. So okay. So I'm just gonna read this. to you guys. So we use the next code cell to pre-process your text data. Make sure that you use a method that agrees with how you pre-process the training and validations, and set the pre-process test features to final X test. Then use the pre-process test feature and train model to generate test prediction process. In order for this step to be marked correct, you only ensure the pre-processed test data frame has no missing values, and the final X test has a number of rows as X test. Okay,